Okay, so far we've been doing 2 by 2 systems. In other words, we had something maybe like 2x plus 2y equals 3 and x plus 3y equals, I don't know, 6. This would be a scenario where you got 2 variables, so if you're going to solve it, you're going to have 2 equations. Well, what you'll notice is now we've got 3 variables. I got a p, I got a q, and I got an r. So if I'm going to have 3 variables, that means I'm going to need 3 equations to solve it. I've set this up so that you can kind of see how it works in a step-by-step scenario. So what I want to start off by doing is labeling. We're going to have A, we're going to have B, and we're going to have C. Given those 3, I then want you to highlight the one that has the isolated variable. Okay? That would be our step 1 right here. Step 2 says to substitute the expression with the isolated variable, in other words, our highlighted one, into the other equations. And then after that, we're just going to combine like terms and simplify it. So, if I'm going to do that, that means I'm going to take my 2 other equations. This could be A. The variable I'm going to replace is P, because that's the one that is isolated. So, every time I write a P, I'm going to put parentheses instead. So that means 4, since there's a P, there's my parentheses, minus q plus r equals -4. This would be my A1. C is the other one we're going to substitute into. So I got negative p, so there goes my parentheses, plus 2q plus 3r equals 9. Okay, based on those 2, now I'm supposed to substitute in this into each of these equations. So that means I have 2r minus 8 in both. What I'd like for you to notice about each one of these new equations is we've now made the p go away. We only have r's and q's left. So now if I were to go forward and simplify, I got 4 times 2r, which is 8r. 4 times -8, -32, minus q plus r equals -4. I got some like terms I could combine. My 8r and r will give me 9r. Minus 32 minus q equals -4. Then I could add 32 to both sides, giving me 9r minus q equals 28, okay? Notice my p is gone. This is like equation we've been doing. So now if I come over here to my c equation that's been substituted into, I got -2r plus 8 plus 2q plus 3r equals 9. Please keep in mind, this is like having a -1 up in front, so that's why my -8 became a positive. Once again, let's combine our like terms. We're going to end up with -2 plus 3r, which is r, plus 8 plus 2q equals 9. Subtract 8 from both sides, and I get r plus 2q equals 1. So now this is my second equation that p has been eliminated from. So now I'm going to bounce down, and it's going to give you a note. Now you've got 2 new equations, and you got the same 2 variables.
Mr. Hacker, please call the front office. Mr. Hacker.
So given that scenario, I now want to take those 2 equations and eliminate like I always have done. So if I'm looking at this, I personally think the q's would be easier to eliminate. So when I look at that, I've got a positive 2q, so I need this one over here to be that negative 2q. To get that to happen, I need to multiply this by 2. So if I do that, I get 18r minus 2q equals 28. And then I'm simply going to take this one and write it down below, lining up my like terms. So when I do this, you'll notice there went my q's, they've canceled out. I've got 19 r's, and then I got 29. Oh, no. That was 2 times, this is supposed to be, sorry, ooh, big mistake, 56. So let's change this to 57. If I divide both by 19, I get r equals 3. Okay? Now that I have r equals 3, I can plug it into one of these 2 equations. Or if you'll notice when you go back up to the top, p equals 2r minus 8 was our b equation up top. Since I know r equals 3, I could say 2 times 3 minus 8 equals p, which means p equals 6 minus 8, so p equals -2. So far I've got r and p. I still need q. So I need to take these two values and substitute back into one of the equations up top. Doesn't matter, I mean, B's not going to do you any good. I kind of think C might be the easiest, so I'm going to go with C. -p plus 2q plus 3r equals 9. P equals -2 plus 2q plus 3r equals 9. So now I just need to simplify. This is going to be a positive 2 right here, plus 2q plus 9 equals 9. And then I got what? 2q plus 11 equals 9. So 2q equals -2, so q equals -1. Then the last thing we would do would be to write these as a triplet. You always write them in the order of P, Q, R. So P was our what? -2. Q is our -1. And R was 3. Okay? This works well when you have one of your variables by itself. But if you look at our other scenario, you'll notice in this case, these are all set up for elimination instead. So going through this scenario once again, I'm going to go ahead and label my equations A, B, and C. It suggests for you to line up your variables of any two of the equations. So when you do this, for example, my first one, I'm going to go with AB. When I do this, I have to be thinking about what I'm going to eliminate. I think it would be real easy to eliminate x if I multiply the top one by -2. So A would become -2x minus 4y plus 6z equals -22, while B would remain 2x plus y minus 2z equals 9. Based on that, you'll notice my x's disappear. Once again, getting me down to two variables. And let's see. Okay, so that was my AB. Now we need to do it again, but we have to choose two different equations. So this time, once again, it's up to you, except that you must still eliminate the x. So if I were doing that, maybe I could do A and C. So looking at A and C, let's see. I once again need to eliminate my x's. So if I were going to do A and C, maybe I would multiply by A by -4. So if I multiply A by -4, I get -4x minus 8y plus 12z, oops, I didn't write that very nice, minus 44 equals -44. That's a 12. That totally doesn't look like a 12. Whoops. Oh, this board. Okay, that's a better 12. Okay, so that would be that one. Then if I'm going to do C, well, C is just 4x plus 3y plus z equals 16. So once again, I'm just combining like terms. So given that, you'll notice my x's are going to disappear. I have -5y plus 13z equals -28. So these two are your significant equations that you're going to now work to eliminate the y or the z. Okay, so now what you'll notice is they want you to take those 2 by 2 equations and we're going to eliminate either the y or the z. Looking at that, it really just depends on you, what you think is going to be easiest. I'm going to take this AB equation and I'm going to multiply it by -5. That's going to give me 15y minus 20z equals positive 65. Then I'm going to take my other one and multiply it by 3, which will give me negative 15y, which now eliminates my y's, plus 39z equals negative, let's see, that's a 4, 3, 6, 84. So now if I were to combine these two, I'm going to eliminate my y's, and I'm left with what? 19z equals negative, $19. Oh, struggling with a little math now. So z is going to equal negative 1. Now what you'll notice is we've got an answer, okay? We got 1. I now need to take this answer and plug it into one of my box equations, either my AB or my AC, whichever one you think would be easier. So when I look at those two and I think about my Z, I'm kind of looking at those smaller numbers. So I would tend to plug it into the negative 3. So let's see, we got negative 3, looking for it, negative 3, hold on, I lost on my piece of paper, y, plus 4 times z, which is negative 1, equals 13. So that's going to give me negative 3y minus 4 equals 13. Negative 3y equals, add 4, is that a negative 13? That's a negative 13, my bad. Add the 4 and I get negative 9, and so then I got y equals 3. Based on that, you've got two answers now. You got z equals negative 1, y equals 3. So then you go back up to your original ABC questions. You substitute your two solutions back into there. So if I were to substitute, I'm looking at, I think A would be the easiest. So I would use A, x plus 2y minus 3z equals 11. I know y is 3, I know z is negative 1, and I don't know x. So that gives me x, this right here is 6 plus 3, so x plus 9 equals, that's 11, not 1, my bad. Subtract it and I get x equals 2. So then the last thing you do is you write your system as a triplet. So we'd have x, y is 3, and z is negative 1.